Welcome to the Storage Developer Conference. I'm Steve French. We'll be talking about the future of accessing files remotely from Linux, an update on the SMB3.1.1 client and server. I'm here with Shyam Prasad as well. We work for Azure Storage. As a reminder, these views don't necessarily represent the views of Microsoft. I'm a member of the Samba team, and I'm the author of the Linux cifs VFS, the client for cifs and SMB3. I'm a member of the Samba team, and I work for Microsoft in Azure Storage.
Hey, I'm Shyam Prasad. I work for Microsoft India, and I contribute towards the Linux cifs file system.
So we're going to be talking about some general activity in Linux, then focus a little bit on the changes in the Linux client and server, talk about recent improvements, and then we're going to talk about the features you'll be expecting soon, but then we're going to do a deep dive into one of the more important sections, one of the more important areas of the client, how to use Kerberos and multi-user mounts. Then we'll finish up with some discussions of related components and also the improvements in testing. So a year ago, Linux was at the 5.3 kernel, and now we're at the 5.10 RC1 kernel. If you notice, Linux has very colorful names with unusual animals many times, and we're at kleptomaniac octopus. And hopefully you guys can find a better picture than I could, but that's the best I could find. So I want to give some general background on how cifs and the Linux cifs VFS fits into the larger ecosystem. As you probably know, Linux is enormous. It's more than 20 million lines of code, and file system activity represents almost 7% of the changes in a typical year. So it's obviously one of the most important areas. It's part of the core kernel and one of the most actively maintained areas of the core kernel. There are more than 60 file systems, but only 6 of them and the VFS layer itself drive the vast majority of activity. And you can see the examples of these. You've probably heard of many of these: BTRFS, XFS, NFS, and cifs, and then slightly less active ext4. The file systems represent almost 5% of the kernel source code, but they're watched very, very carefully. I get emails from automated test systems and from unexpected developers many times a week. The activity for cifs, though, is unusually strong, so most people don't realize that it's the third most active file system over the last 2 or 3 years. And it's also maybe larger than some people realize. It's larger by far than the average file system. And then that doesn't count the Samba itself, which has many tools that cifs relies on, as well as the cifs utils package, which we rely on for the mount helpers and various user space tools like SMB info. So over the last year, BTRFS had over 1,000 changes, but the cifs client had 336, and it's actually higher than that now. This was measuring it in the 5.9 RC4 kernel. And just to give you some contrast, the NFS server in Linux is almost 100 times larger than Samba. There's also now a kernel server, and we'll talk about that in a little bit for SMB3. But it's very important to realize that the activity for SMB3 is huge, and it's extremely important for a wide variety of workloads. It's also important to realize that what we work on Linux is not the same as POSIX. If you look at how Linux evolves, we had 3 syscalls added very recently. And here are some examples of recent additions to syscalls that affect file systems. And it's important for us to realize that as a file system developer, we're having to deal with more than 200 syscalls and making sure they behave well for a wide variety of applications. Maybe the good news is no file system does this well. The bad news is no file system does this well. We have a lot of work to do to optimize for each of these. And of course, in many cases, the focus has been on local file systems, not network file systems. So it's important for us to continue to improve this, because every single release we're seeing new API calls, new flags being added that we have to adapt to and extend the protocol for. So what are some of the discussions that are driving all this activity? Some of it is improvements to FS cache. I have a call with Dave Howells coming up pretty soon. We're going to talk about a rewrite of the FS cache that he's proposed. There's a new mount API that came a little over a year ago that allows much more granular error codes to be reported. They've, about 2 years ago, extended the information you can query on files and file systems. But there is an update proposed to allow extending query FS information much more broadly. There's also new notification mechanisms being proposed, and there's been a discussion about user ID mapping for containers. And there's continued discussions about how to deal with this much faster storage, NVMe over RDMA. And over the last 2 years, you've seen a lot of discussion about async I/O, especially a new API called I/O U-ring. And of course, what we deal with in Azure a lot is this longer latencies. In some cases, you'll have 2 orders of magnitude difference in performance because of the location of the clients and servers in the cloud. And this is important to realize that many workloads are shifting to the cloud, and that drives file system changes as well. But I don't want to forget talking about the server. Samba server is amazing. Over 3 million lines of code. And there's been a lot of activity on Samba. So I want to refer you guys to Samba XP for more information on this. But we also wanted to note that we have a new kernel server. Namjay has done some good work with his team. It's more than 30,000 lines of code with a set of user space tools as well. Originally, it was called cifs.do. The module itself, though, needs to be called ksmbd for a couple of reasons. One is to distinguish it from Samba's SMBD, but also to remind people that it's a kernel module, much like NFS has nfs.ko and NFSD. We have ksmbd as the name for the module that the new kernel server is. And this has been a very exciting change. Here you see an example of it. We're mounting to the kernel server. There's a GitHub tree you can look at to see the source code, but we expect to be sending it upstream pretty soon. It passes more than 98 XFS tests, and it's already being used in various open source projects, toolkits, and being shipped with various embedded systems. Here's some examples I list on the slide, like OpenWRT. And many issues have been fixed as a result of ksmbd being distributed more broadly. And the activity is pretty strong on it. So some of the things that are being worked on in progress are support for ACLs, adding support for Kerberos, multichannel, adding support for backup intent flags. It's an exciting time. So the things that they did were removing SMB1. You don't want to have any cifs code in it, so we don't have to deal with security issues as much. And they've cleaned up a lot of the code. They've fixed many build errors. We are working on trying to better integrate the testing with the build bot that we use, and also get better visibility for the testing that Namjay's team is doing. Now, let's switch gears to the broader topic of SMB3.1.1 and Linux. So why do we care about SMB3.1.1? Well, it's the broadest file protocol. It's supported on the broadest set of devices, and it has the largest set of function. And we want SMB3.1.1 to be the fastest general purpose way that we access file data, whether it's in the cloud, like in Azure, largest server in the world apparently, or on premises, whether it's a virtual machine or whether it's physical hardware. And we have to be able to implement all the reasonable Linux semantics. Now remember that this is a lot bigger than POSIX. This isn't just a set of 100 syscalls. This is many hundred syscalls we have to deal with. And we want to make sure that apps don't even know they're running on a remote mount. The distinction between a local and remote mount shouldn't be that big a deal. And as Linux evolves and we continue to add features for new workloads, we have to be able to quickly add them to the Linux kernel client and Samba so we can adapt to these workloads and optimize well for them. Now let's talk about some of the exciting progress over the last year or the last 13 months. The mode from SID mount option, here you can see it allows us to map mode bits much more accurately. In This allows us to handle workloads where we have a sort of NFS style of security. In other words, where the client's permission checks may matter more because only the client knows what UID is what. And the way mode from SID works, it stores in a special SID in the access control entry and sort of unenforced permissions that are encoded in a way that the client can read. This is the same way that the NFS server for Windows stored the mode bits. And if here, you can see an example here, but all 4096 combination of mode bits works this way, where if you use cifs.ko and try to emulate them, there's some sets of mode bits that are not mappable into ACLs. And one of the more exciting performance features was multichannel. And thank you to Aurelian at SUSE for doing this. This is a big performance win. And it provides, in some cases, up to 5 times faster performance. And I find it extremely exciting. We're still working on stabilizing this, so consider it somewhat experimental until the 5.10 kernel is out. But we're seeing very, very good performance improvements with it. The ability to parallelize I/O, not just on the wire, but also in how we process it on the client and server, has provided a significant performance advantage. Here's an example. You can see the different colors represent each channel that's being used. And you can see on this that these requests are being sent on different network adapters, and it's allowing much higher performance. One of the other big improvements we've done is add dynamic trace points. eBPF in Linux has been fantastic framework for doing dynamic tracing. And as cifs adds more and more trace points, it makes it possible to debug more effectively. We actually added one just last week, and we've got a couple more under review. These are allowing customers to get a better idea what their workload is actually doing over the wire, because clearly there's a big difference between what an application thinks it does and what it's actually sending over the wire. But it also allows better error analysis and more rapid response when a customer reports a bug. So what about other performance features? In modern hardware, most processors support offloading of encryption. And this offloading works with GCM. Previous versions of the Linux client only supported CCM. By adding support for GCM on the client, which was added in the 5.3 kernel, we were able to get about double the write performance and 80% for read, 80% faster for read. In my experiments, it was about 5 times faster, the algorithm to compute the encrypted frame using GCM than CCM on a typical virtual machine that I experimented with. And the end result is, obviously, like you see here, almost twice as fast for read and twice as fast for write. It's a huge performance win. It's also supported in Samba now. And so in the last year or so, Samba's added support for it as well. And this basically means for encrypted mounts, we're able to get better performance than signed mounts had before, which is incredible. Paolo at SUSE added support in the 5.5 kernel to allow us to boot a diskless system over cifs. That was exciting. And here are some examples of how to configure that. There are many, many changes we've made, and some of this is for reference, but going release by release and seeing these improvements gives you an idea of how active the development has been. Here, for example, we've cut the number of requests we have to send on an open from 3 to 2 in the 5.3 kernel. That improves performance. And there are many features that have been added in the 5.3 and here in the 5.4 kernel. The 5.4 kernel, for example, added the ability to decode encrypted traces in Wireshark. 5.5, we added support for the BSD-style whole file locks, FLOCK, and added the multi-channel performance. 5.6, the mode from SID mount option that we talked about was added, and reader performance optimization, cutting a couple round trips when you do an ls command, improving performance. We added an ioctl to allow you to do change notify, so you can have an application wait on events, wait on a new file being added, for example, to a remote system. In 5.7, we significantly improved RDMA, added the ability to have a swap file mounted over SMB, And we made a big performance improvement for signed connections. Now, in 5.8, we significantly improved the performance of multi-channel. And we added support for IDs from SID, which is an alternate way of handling chown. In many cases, the server has no idea who a particular Linux UID is, and being able to embed those better into the owner using IDs from SID can provide much better POSIX semantics because we can more accurately return the owner group and the owner user. And we've also significantly improved the POSIX extensions. These SMB3.1.1 POSIX extensions are still experimental, but they allow better Linux compatibility for some workloads. In the 5.9 kernel, we made some key DFS fixes, as well as improving IDs from SID when you're creating a directory. In the 5.10 kernel, we've added support for experimental GCM 256. That's stronger encryption. And so those workloads that require the most secure encryption algorithm are now possible with the GCM 256. We added support for recognizing the reparse points that are used by Windows services for Linux. So if you mounted to a Windows server whose Linux Windows subsystem created special files like FIFOs, we can recognize them. We added a performance improvement for querying the root directory. And then we made some key fixes. So we also added support for returning the ownership information with the SMB3.1.1 POSIX extensions. Now, in the near future, what do you expect? We expect much faster GCM signing. So GCM encryption has long been supported, but GCM signing will allow signing to be faster than encryption again, and that's useful in some workloads. There are going to be improvements that Sham's working on for cifs.ko. There are a set of caching improvements that are very important, being able to cache a file across close, and also being able to extend directory leases beyond the root directory. Today, we're able to cache the information for the root directory by using a directory lease, but we don't extend that to allow caching of directory metadata underneath the root. And extending that for servers which support directory leases will provide huge metadata performance improvements on reducing the number of queries we do for the files, date and timestamps, for example, and file type. We're continuing to look at things called compounding. Compounding is an SMB feature that allows reducing the round trips sent from client to server. And there are sets of commands that can be sent as one across the network, providing better performance. We've gradually been doing this, for example, stat, for example, unlink, and ls. But as we continue to look at cases where we see commands that can be collapsed into one, that improves performance and optimizes the amount of network traffic we send. We're also working on some important fixes for multi-channel. Right now, multi-channel, when you reconnect, has a few bugs. So if the server went down and then came back up immediately, or all the network connections went down, there are some cases where we're reconnecting improperly. Those are being fixed. And we also have work in progress. We did the first stage of it in the 5.10. We plan to finish the rest of it in the 5.11 kernel for supporting the new mount API. And we have discussions ongoing with Dave Howells and Ronnie about improving the FS cache support as the new FS cache mechanism in the kernel, VFS, rolls out in the next release or two. This will improve the ability to do offline caching, sort of lossy caching of network files to a local disk cache. There are many cases where loose caching semantics are fine, and we can take advantage of the Linux FS cache subsystem to provide much better performance for some workloads. Now, what we're going to do now is I'll switch to Shem, and he'll get a chance to talk about some of the exciting Kerberos changes we've done and do a deeper dive into Kerberos, multi-user mounts, and Azure.
Hello, everyone. The topic I'm going to cover today is the Linux SMB3 client access using Kerberos. So the concepts explained in the next few slides apply to any file share services, although I'm going to cover specifically the Azure file share. So about a bit of background about how SMB access can be done to Azure file shares. So Azure file share is a file share service which is running on Azure. So you can access these file shares both from the Azure VMs that are running on Azure, as well as the SMB clients that are running in, outside anywhere on the internet. Although if it is running over the internet, one key requirement to look for is that the port 445 should not be blocked in any of the path between the client and the server. So this can be a hindrance sometimes, since some of the internet service providers tend to block this port. Another requirement is that if the traffic flows over the internet, Azure makes encryption mandatory. And so you'll need SMB version 3 or above which support encryption in order to do the file access. So by default, NTLM SSP is a mode of access of Azure file shares from Linux or any SMB clients. So the Azure provides you with a username and a password, that the credentials that you can use that are used to access the Azure file shares. And once you use those credentials, the server always sees the file accesses as that single user, that the username that is provided to you. And the local client user that you are using doesn't really matter. And so hence there is no concept of access control between the multiple users. So if you want access control today, the mode of access is using Kerberos and Active Directory. So for Linux clients, this is not something that is officially supported by Microsoft yet. It is still in early testing phases. However, this is something that I've been working on for the last couple of months. And the way you can do that is by joining the Azure storage account, which hosts all your file shares, to an Active Directory domain services. So these Active Directory domain services can be Windows ADDS or Azure ADDS. You have good amount of public documentation on Microsoft in order to how you can enable these services. So once enabled, the Linux VM, the client VM, needs to be joined to the same domain. So in order to be able to join Active Directory domains, you have a couple of well-known open source softwares, which are Winbind and TripleSD. We can use either of these softwares, and there's again good amount of documentation available on the internet on how you can do this. So once the domain joined, the Active Directory users will then be able to log into the Linux client host. So here are some screenshots of an Azure VM, Linux VM, that is joined to the domain linuxdomain.com. The Active Directory user lxsmb admin2 is can be used in order to log into the client VM, since it's already domain joined. So once logged in, you will notice that the klist command is going to output some details. So what these are nothing but Kerberos tickets. So some details about how you can now access the Azure file share as these users. So in order to access Azure file share using Kerberos, what you need are Kerberos credentials. And in the previous slide, whatever the klist command gave you the output are nothing but Kerberos credentials. These are called Kerberos tickets. And these credentials can be used to identify by the server to identify the user that is accessing the file share. And further access control can be configured both at the file share level as well as the file or directory level using ACLs. So one of the key mount option to talk about here is the multi-user mount option. By default, if you don't specify this mount option, you're going to access the file share even with Kerberos as a single user. And that single user will be the user with which you mount the Azure file share. But with a multi-user mount option, the multiple Active Directory users can access the same file share using their own Active Directory credentials, the Kerberos credentials. Here are some screenshots again. So what I've shown here is that there is an fstab entry which mounts an Azure file share, LX SMB share 1 on a mount point using the options sec equal to krb5, username as lxsmbadmin2, and multi-user mount option in order to allow multiple users to access this mount. Next, I perform the mount. And once it is successfully mounted, I can then switch to any of the Active Directory users on this client. And the winbind is going to fetch me the Kerberos credentials that are needed to access the file share. And if this Active Directory user is allowed access to this file share, then I should be able to cd to this mount point and then perform file IO. So one of the difficult challenges with this approach is that you may have noticed in the past few slides, the screenshots which I have shown you, that in order to be able to access the file share, you need the Kerberos credentials. And these Kerberos credentials are, to get these Kerberos credentials, the user will be asked to enter the password. And the Kerberos tickets that are the credentials that are acquired are stored in the Kerberos credential cache, which may be in the file system or in the memory. So either way, when you reboot the machine, it's very likely that the Kerberos credential cache may be cleared. So this poses a challenge wherein you need to authenticate with the Kerberos server at the time of reboot. So the way to do it is that the Kerberos offers something called keytab. So keytab files are nothing but files which hold your Kerberos keys, which are nothing but password in most cases. So what you can do is you can encrypt your password into this keytab file, and this keytab file can then be used by the Linux cifs modules in order to acquire the authenticate with the Kerberos server at the time of mount. So with these keytab files, with keys entered in the keytab file, you can have an fstab entry in order to mount the Azure file share at the time of mount. And it would, in fact, mount the file share by the time you log into your account. And then you will be able to access the file share using the multi-user, if it's a multi-user mount option. So a bit screenshots of how the keytab file can be used. So by default, so kinit is a tool that can be used in order to perform the Kerberos authentication. So if I do kinit as this Active Directory user, lxsmbadmin2, it is going to ask for your password. However, if I enter this password into a keytab file, as I've shown here, keytab file already contains the password of lxsmbadmin2. And now if I do a kinit with this keytab, it's not going to prompt you for password since it already finds the password within the keytab file. So any of the Kerberos tools can use this keytab file. And that is what the Linux subsystem does. All right, thank you.
Okay, so let's switch gears to one of the features that's going, another security related feature that's going into the 5.10 kernel. And here you have an example of a Wireshark trace of us negotiating the strongest encryption, AES 256 GCM, with the server. And currently, there's one more change that needs to be made to negotiate this. And we have a new global mod info parameter that can be set. Here's an example of setting that lets you experiment with the new GCM 256 encryption context. And this is very, very exciting if you need support for the strongest encryption in these workloads. And here's a trace of the mount to Windows. Now let's also talk about another encryption feature that's extremely important. We have a fairly significant problem with port 445 being blocked in some environments. I was on a recent trip, stayed at 3 different hotels on the way to drop some things off for my son. 2 of the hotels allowed me to access Azure, allowed me to access port 445. I could save presentations. I could work on presentations, save them to my laptop. A Mac developer sitting in there could be backing up his Mac to Azure while sitting in the hotel room. But one of the 3 hotels blocked port 445. Where I'm sitting right now in Austin, port 445 is blocked from one of the big ISPs, but not the other. Where my son lives, they don't block port 445. It's a significant problem when 20 or 30% of the ISPs are blocking port 445. And one of the ways around that is to use something called QUIC. QUIC carries a significant percentage of the HTTP traffic today, but there's an obstacle. Even though you may have seen the talks at the Storage Developer Conference, the virtual one a few months ago about QUIC in Windows, there's a key gap in Linux. There's no network driver for QUIC in the kernel, and that issue is being discussed, how to get a network driver for the QUIC protocol merged into the kernel. And perhaps we could open source the Microsoft QUIC open source project, which already works on Linux and user space. There's an MS QUIC project if you want to look at it in more detail. We could use that as a starting point, but it would need to be converted into kernel style. Right now, it doesn't use kernel style guidelines. So these discussions are continuing about how we can get a QUIC driver in the kernel and then test that against Windows and other servers that'll allow us to use QUIC as a way of having encrypted traffic going between SMB client and SMB server and avoid the problem we see today where a significant percentage of ISPs will try to block port 445. This is less of an issue inside the data center, but it is a big issue. Well, take this example, this presentation, right? We'd love to be sharing this presentation in Azure without having to do complex VPNs. So this work on QUIC is very exciting, and any ideas on how to get a QUIC driver in the Linux kernel faster would be appreciated, and would be worth talking about it on the Linux cifs mailing list. So also notice that Wireshark now has support for decoding QUIC. Now, there are other security improvements being discussed and being in progress. One of them is how to integrate SE Linux better. Another is supporting a broader set of scenarios. We basically have 3 scenarios now, sort of a client-focused one where the access or the mode bit evaluation is done on the client. Typically, you're using IDs from SID and mode from SID mount options in that case. We have the multi-user example that Sham was talking about, where you're using usually Kerberos and multi-user, and in some cases cifs.ko to emulate the mode bits, and where permission checking can be disabled on the client, no perm, and all that matters really is the permission checking on the server. The third model, which is most common, is using defaults, using a default mode, default owner, default group owner, and that's obviously the fastest performance because it requires fewer queries of security information from the server, from the file system metadata, but it limits what workloads can be run on it. So we have three cases, sort of a client focus, sort of like NFS, where you use IDs from SID, mode from SID. We have the multi-user Kerberos cifs.ko case, where permission checks on the client really don't matter at all, and all that matters is the server permission checks, and then the default case, where user ID and mode are set to the default. There are lots of improvements in other areas of this, and I wish we had more time we could talk about this, but SMB info tool is worth taking a look at. It's been completely rewritten. Some of these cifs utils are quite helpful. There's now a pass-through fsctl and query info and set info, so you can extend user space tools to do many things that were not possible 2 or 3 years ago. Basically, just open a file, and many features can be done simply by passing through fsctls or set info calls. There's a recent examples of this, how it was used. One of the Red Hat developers, Kenneth D'Souza, wrote a tool called SMB2 quota to display quota information from the file system. Here's some sample output of SMB2 quota from Kenneth's tool that's now in cifs utils. Now, one last thing. There are many mount options, like over 100 of them, and it gets confusing. The ones we frequently recommend you use are MF symlinks, and then in the example we talked about with Kerberos, you're often mounting with no perm. If you're not using Kerberos multi-user, you may be setting dir mode, file mode, UID, and GID. These are very frequently used. Now, some examples of ones that are used a little bit less frequently, you can see below. An example might be seal to force encryption even if the server didn't require it. Many servers like Azure do a highly reliable backend storage, so there's no need to pass the sync calls across the wire to Azure because they're already highly reliable. So you can improve performance somewhat with the no strict sync mount option. So these are examples of mount options that you really should pay attention to and understand to see if it maps in your workload. In cases where metadata queries are overwhelming your workload, causing slower performance, mounting with a larger AC timeout than the 1 second default can be helpful. cifs is a little stricter than most file systems by only allowing you to cache metadata for 1 second. So setting it to a larger number is usually very safe. And I want to leave you guys with one big thought. It's extremely important that we keep improving testing. There's a wide variety of servers, many of which have strange bugs, and we have to be able to continue to improve the regression testing. We've done an enormous, had an enormous improvement over the last 2 years in this, and you can go see the wiki for examples of this. It's very easy to set up XFS tests. It's very easy to set up exclude files. And in our build bot, you can get an example. You can see the web page here of the tests that run against various server targets, not just Azure, not just Samba, not just Windows. And there are 180 groups of tests that can run over SMB3. That's more than NFS, and more are being added every release. So let's keep up this improvement in regression testing because it also helps drive new features, and it also has been invaluable in improving the quality of this SMB3 client. Once again, trying to get our goal to make this sort of the commodity protocol, the standard protocol for accessing storage across the widest variety of devices possible. So let's continue this work and make the 5.10, the 5.11, the 5.12 kernel continue to be the best releases ever for SMB3, and to be able to extend SMB3's use into a much wider variety of workloads. And I want to thank you guys for your time. And let's encourage you to go to the cifs mailing list, Linux cifs, as well as Samba Technical, to ask any additional questions. And there'll be an opportunity to ask us questions during the talk today, during the Q&A today. Anyway, thank you again for your time, and we look forward to hearing more about your requirements and your experiences.